now that we have discussed the overview of the Big Bang Theory, how do we know that the Big Bang Theory is actually true? Of course, like all theories in science, it must have evidences. And that's what we're going to discuss in this video. Okay, so evidence number one is called Hubble's law. So this has been proposed by Edwin Hubble. If he sounds familiar to you, that's because he is the inventor of the Hubble Space Telescope. So he discovered a certain phenomena in 1929, and that's the observation that the galaxies are moving away from the Earth. So if you can imagine, all the galaxies are moving away from the Earth, and that is supporting the idea or the claim of Big Bang Theory that it triggered the expansion of the universe and is still continuously expanding today. So how did Edwin Hubble arrive to this conclusion? Okay, so there is something called a redshift. When it comes to the behavior of light, there is a visible light. We have a spectrum. So the longer wavelength rather is here at this part, color red, and the shorter wavelength is color blue. Now, when we are looking at space, this length of the waves or the wavelength have a certain effect when we are observing it. If the object or the star is moving away from the Earth, it's usually color red, and if it's color blue, it's usually color if it's color blue, it's moving towards the Earth. And since the galaxies are moving away from the Earth, it's observable as color red, and that phenomenon is called redshift. Okay, so we can observe by simple telescope that the galaxies are moving away from the Earth in a phenomenon called redshift due to the expansion of the universe. Okay, so that's evidence number one. This again supports the claim of the Big Bang Theory that density of matter decreases over time. So if you can recall, Big Bang is the universe started as a small space and it contains all the matter and energy within it. But since it's expanding continuously, more and more space, but the matter and energy within our universe is fixed. So it's not going to multiply in the future, it's fixed. All matter and energy is fixed. So the density of matter is fixed, and the density of matter decreases because matter is fixed. When space, we're having more and more space, thus the density of matter is decreasing. Okay, so what does that mean, or what's causing this strange expansion? I mean, matter should follow the laws of gravity, and if we follow the laws of gravity, all matter should actually move towards one another because gravity. But what we are observing in the huge universe is that we have more and more space, and we are actually expanding in an accelerating rate. So what's causing that expansion? So far, scientists had labeled the culprit for that expansion as dark matter or dark force. It's called dark matter because we don't know what's actually is dark matter. It's a more of a mysterious entity in our universe, and several of our scientists are actually studying it in order to figure out why are they causing this expansion. Okay, so much for evidence number one. Let's move to evidence number two, and that involves two famous inventors, Arno Penzias and Robert Wilson. Okay, so way back then, Arno Penzias and Robert Wilson teamed up and wanted to build a very sensitive radio station because their idea is that they will create a radio station with a very clear signal and then sell it to the radio stations. Okay, because the mode of communication before, there was no TV back then, just a lot of radios. So they wanted to make a very good radio station or radio satellite. But what they discovered is, regardless the way they calibrate the radio satellite, it's still picking up a small static. So they tried to recalibrate the object and the static is still there. They tried to move the satellite, this part right here. Let's get my marker, pointer. This part right here that's actually movable, they tried to put it in a different direction or direct it into a different area, and it's still picking up that static. They realize that birds are pooping on top of the satellite, so they kill those birds, but the static is still there. So what's wrong? So they consulted some physicists and realized that they have discovered a certain something called the cosmic microwave background radiation. So this cosmic microwave background or radiation, if you can recall from the previous video, is like a footprint of the Big Bang event. Since the Big Bang event is so powerful, it left a footprint in our universe called cosmic microwave background. So it's a 2.725 degree Kelvin background radiation in the microwave range, so very small, that pervades all of the known universe. Okay, and this was formally discovered by Arno Penzias and Robert Wilson. They were awarded a Nobel Prize for their discovery. Okay, so we have a footprint of the Big Bang theory, of the Big Bang event, the cosmic microwave background. So that's evidence number 2. Right, let's just shift my slide. Okay, evidence number 3 is the relative abundance of light elements. If you can recall, the Big Bang theory claimed that the further expansion of the universe led to the cooling down. The cooling down have led to the separation of matter and energy, and eventually the formation of light elements, hydrogen and helium. Logically, if you think about it, since the first elements that were ever formed were the light elements, hydrogen and helium, they should be the most abundant element in our universe, and that's actually correct. If you readily survey the ordinary matter in our universe, most of our elements are hydrogen and helium. So our universe is mostly made up of 24% helium, 74% hydrogen, and 2% only of the other elements. So supporting the chronological order of events proposed by the Big Bang theory. Okay, so I hope you remember that. Evidence number 1 is redshift. Evidence number 2 is the cosmic microwave background or CMB. And evidence number 3 is the relative abundance of light elements. Okay, so next slide. Okay, so one good question. We have already answered the question, how did the universe begin? Let's go to the next big question. What is the fate of the universe? How will the universe end? In ice or in fire? So there is a positive look at the universe. So there will just be an eternal inflation of the universe. So our universe will just continuously expand and probably trigger the formation of another universe. So I know you are familiar with the concept of a multiverse, because if you can recall, we have mentioned that the beginning of our universe is because of a particle, a super dense particle called a singularity. But where did the singularity come from? What triggered the Big Bang? We don't know. Probably it's the inflation of another universe. So a universe parallel to us may have caused the Big Bang. So that's one proposal, that our continuous inflation of the universe will trigger another Big Bang theory, a Big Bang event, thus causing an expansion of a new universe. Okay, so that's a very positive look into it. And there's another more grim look into it. So we have something called the oscillating universe theory. So according to this, there will be a certain event called the Big Crunch. So the Big Crunch is a situation that scientists predicts that the universe will end because our expansion cannot last forever. So according to scientists, we will For example, here, the Big Bang event, we will continuously expand, but the universe can no longer sustain that maximum expansion, and thus the big crunch will be triggered. So during the big crunch, the universe will implode into itself, it will close, and then go back into nothing. Okay, so if we will compare it, the open universe or the eternal inflation, we will just expand, expand, and expand continuously. But the big crunch event or the oscillating theory states that we will just reach a maximum and then close until nothing. Okay, so that's two theories. You may be thinking about the big crunch event right now, but don't worry, we are still far from the maximum expansion point that scientists are hypothesizing, and will be far gone if ever this occurs. Okay, so that should end our discussion to the formation of the universe. So with the formation of the universe, of course, it led to the eventual formation of the Earth. This is a very iconic picture taken by NASA in December 7, 1972, and it's showing you the view of Earth from Apollo 17. Okay, so we will discuss more about the formation of the Earth in our next video. That's all for now. Stay safe. Bye.